Now, as I've said earlier, RCN is a very important compound. It is of immense use. So how it is? Now, RCN. So, if I go for reduction, now if I use here sodium and alcohol, ethyl alcohol, it is known as Mendius reduction. Remember that, the name. What I said? Mendius reduction. It is said to be S. Okay. Then what I am going to get the product. Now, second is that if I go for partial hydrolysis. Partial hydrolysis means what I am going to do it is that I am going to go for hydrolysis in presence of, that is aqueous medium, that is alkaline medium, alkaline hydrogen peroxide. I can take it, alkaline hydrogen peroxide, or I can take it, that is nothing but acid, a concentrated acid under low temperature. I can take it. What is the product? Now the last is that I'll go for complete hydrolysis. Now here I am going to take a very strong acid, a mineral acid, a dilute mineral acid. I am going to take it here. That is in presence of H plus. Here also H plus can be taken. Here also H plus, but under low temperature. Remember that. Okay, or under alkaline hydrogen peroxide. So this is said to be as partial hydrolysis. This is known as complete hydrolysis. So it's here 2HOH I am taking it. So here you can see the three different products I am going to get it. This is your reduction. These two are hydrolysis. This is partial. This is complete hydrolysis. Okay. Now, when I am going to reduce this, it is going to undergo reduction. What I am going to get it? RCH2NH2. That means it gives rise to 1 degree amine. So this is used for conversions. Remember that. If it will be asked to convert nitriles to amines, we can do this. Now, next is if it goes for partial hydrolysis, what I am going to get it? Amides, RCONH2. Clear? Amides. And if it is complete hydrolysis, what I am going to get it? I am going to get carboxylic acid. Now, you can do it in this way also. Now, listen very carefully. RCN, it gives you RCONH2, partial hydrolysis. One step, 1 HOH. Here also, if you do it, HOH, another one, then it also gives you acid. Either two molecules of HOH you take it, you will get acid, or first you convert to amides, then amides to acid. It is a very, very important one. You will see it will be used in your conversions. We can say that. So this is a very important, what you can say, mind map. I have shown it to you. That is how to do the reduction reaction, and here it is hydrolysis. You can do, you can take any reducing agent, but if I take sodium pentoethyl alcohol, then it is known as Mendius reduction in case of nitriles. In case of nitriles, it is known as. So in this way. Now next is if I take isocyanides and if I go for reduction, RNC, if I go for reduction, isocyanides, then what I am going to get it? I am going to get secondary amines, RNHCH3. This is your 2 degree amine. So what you see is nitriles on reduction gives 1 degree amine, and isonitriles on reduction gives 2 degree amine. So this is a reaction I have said it to you. Next is other reactions are also there of embedded nucleophile. For example, you can see it here, RX, when it reacts with potassium nitrite. Now potassium nitrite, you need to draw the structure correctly. No need to write the molecular formula. See, if you write the molecular formula, then your answer may not be correct. I always prefer that you should write the structural formula. What is the structural formula? KONO. This is the structural formula. Again, it is an ionic compound. K plus and this. What is the product? We'll see it. Similarly, when RX reacts with silver nitride. Now silver nitride, again draw the structure. AgNO2. This is structure of AgNO2. This is the silver nitride, this potassium nitride. This is an ionic compound, this is again a covalent compound. It will be differentiated on the basis of electronegativity, just in the previous case as I have said you, in nitriles and isonitriles. So what I am going to get it? Same thing, R plus X minus, R plus X minus. So this is going to go with the negative one, positive with the negative. So what I am going to get it? RONO. So alkyl nitrite plus Kx. Here what I am going to get it? That is R NO2 plus AgX. So what is this? This is your nitroalkane. And what I said you this is? This is your alkyl nitrite. So potassium nitrite or sodium nitrite will give you alkyl nitrite, and silver nitrite will give you nitroalkane. Of course, these are all alcoholic. We can say that. So in this way, This also is an ambident nucleophile. You can see that this particular one. Here the alkyl group is attached to the oxygen. Here the alkyl group is attached to the nitrogen. Otherwise the molecular formula is the same. We can say that. Clear? This also is an ambident nucleophile. So two different reactions we got it. So next one, if you see the reaction, Rx plus R dash ONA. This is on at sodium alkoxide. Sodium alkoxide. What I am going to get it? ROR dash plus NaX. We can select ROR dash plus NaX. How it is? Positive, negative. R dash positive. This is negative. ROR dash, this is what? This is an ether, this particular one. And this reaction is known as Williamson synthesis. You will study in ether chapter. Okay. Similarly, when Rx reacts with NaSH, this is a thioalcohol. This particular one is. So what I am going to get it? Now this is sodium hydrogen sulfide. This is known as. So this is a thioalcohol. RSH plus NaX. We can say that. So similarly, when Rx reacts with NaSR dash, what I am going to get it? RSR dash plus NX. All these are nucleophilic substitution reaction. All these are nucleophilic. We can say that. See, R reacts with SR dash and Na reacts with X. We can see that. Na here reacts with X. We can see it. That is this particular reactions we are getting it. Okay. So this is known as what? Thioether, and this is known as thioalcohol. We can say. Okay. Next, in the next AV. Thank you.